In this video, we discuss the implementation of angle modulation. The two methods, one is indirect method, the other one is direct method. In the indirect method, there are a couple of steps we need to follow. First step is that we're assuming that the angle signal is very, very small, and using approximations, you see cosine, we're using this cosine A plus B equals to cosine A, cosine B minus sine A and sine B. We use this triple identity to expand this term out. And also, because phi of t is very, very small, so we're going to use this approximation sine x approximately equals to x when x is small. So therefore, I can take phi of t out here. And if we look at this, this is AM modulation. So we're going to use AM modulation first step. This step generate a narrow band angle modulation. The name of narrow band comes from phi of t is very, very small. And after that, we're going to expand it to the wideband angle modulation. We use a frequency multiplier, then multiply by the carrier. That's the indirect method. In this video, we focus on the direct method. The direct angle modulation involved with voltage-controlled oscillator. In this case, we use FM modulation for illustration. We want the frequency varies linearly with the controlled voltage. One way to realize such voltage-controlled oscillator VCO is to use a capacitor whose capacitance changes with the voltage applied across it. For example, one of the devices is a varactor diode. This device is a varactor diode. The capacitance is equal to C0, that's the nominal capacitance, plus K0 multiplied by MT. So MT, that's the voltage applied to the varactor diode, and K0 is a constant, depends on the device, can be positive and negative. We assume the inductance is R0. So now I put the circuits back here. Now we look at the oscillating frequency in this circuit. That will be equals to 1 over 2 pi because we want hertz in the frequency, square root of C of t R0. C of t equals C0 plus K0 MT. We plug it in. That equals to 2 pi square root C0 plus K0 MT. That's 2 brackets R0. So I'm going to plug in R0 into this bracket now. So I'm going to have square root R0 C0 plus K0 R0 MT. Now I'm going to take R0 C0 square root out. Inside the square root, I have 1 plus K0 divided by C0 and MT. So I didn't write this square root, this big long notation here. I have power here half. Next, we're going to design the circuit such that this term is very small. If X is small, I'm going to have this relationship 1 plus X minus half, that's the power, minus half, because this whole notation is half power is in the denominator, is really the power in the minus half. Using Taylor's expansion, that approximately equals to 1 minus half X. So we're going to use this approximation here. I use epsilon here, the same thing. Now I'm going to reorganize this term here. This equals to F0 1 plus K naught C naught MT minus half. We designed the circuits satisfy this condition, and this portion, actually that's the X. That's the X term. So therefore, this approximate equals to F naught 1 minus K naught C naught M T. There's a half here. So this is exactly what I have it here. If we compare this term, this is the instantaneous frequency for FM modulation, and this equals to FC plus KF MT. We can see the frequency is changing with the message. If we plug it in, that equals F naught minus K naught to C F naught MT. So F naught can be the carrier frequency in FM modulation. So this method is the direct method to implement FM modulation. We're using a varactor diode where the capacitance is changing with the voltage across it. Then we evaluate the oscillating frequency in the circuit. This is C, this is L. The oscillating frequency is square root LC. If we want hertz, we divide by 2 pi. So this is the same thing. This is the instantaneous frequency, and the only difference is the capacitance here is a function of time. And we plug it in, we do a little reorganization here, and we want to design the circuit such that this condition holds. And then we can use the Taylor expansion approximation such that this term, this whole term, can be approximated by this term. If we get rid of the bracket, that equals F naught, and this term, the frequency of the circuit is changing with MT, and MT can be the message. This is the idea of obtaining FM modulation using direct method.